Thinking like a product manager is critical for being a good data engineer. And what does that look like? It looks like you build pipelines that actually impact the business, that actually change business decisions. And that can be in a couple different ways. One is you build good metrics that change business decision making. So learning how to develop good KPIs and good metrics is a very powerful way to do that. Another side of it is you build metrics that are impacted by experiments. So if you can learn how to do both of these things, build good KPIs and understand how experiments work and how to plug your metrics into experiments, you will become a much more impactful data engineer. And in this 2-hour course, we are going to be covering all of that. So I'm excited for you to check this out, and make sure to like, follow, and subscribe. So I think this is an important question. Why do metrics matter at all? It really depends on the company and all sorts of different things on like how much metrics matter and how much they actually impact things. I know, for example, like when I worked at Airbnb, for example, metrics mattered less there than at Facebook, for example. Like Facebook was a very, very, very data-driven company. They were all about that data. And I'm not saying Airbnb wasn't. I'm just saying that like a lot of times at Airbnb, they'd be like, well, the data is pointing this way, but we have a design kind of situation where we think this is a better design anyways. And so one of the things that can happen there is it really does depend on who the founder of the company is, of like how much metrics actually matter, because the founder is going to set the culture of the company. And if you look at the difference between Mark Zuckerberg and Brian Chesky, then it becomes very clear why there's a difference in the importance of metrics, where, you know, Zuckerberg, computer science guy, very like nerdy, you know, he's like, I am a robot, right? Zuckerberg gets that vibe, right? It's like if he didn't care about like metrics, that would be like very out of character for Zuckerberg, right? But then Brian Chesky's more of like a design guy. He's more of like an artsy fartsy guy. Like I feel like if Chesky didn't found Airbnb, he totally would have been like a starving artist type. And so like very, very different vibes from those guys. And then like, so how they lead can make a big difference. And so keeping that in mind when you're like working with metrics and working with things, like depending on the company, you might need to have another layer there. Where for example, at Airbnb, one of the big things was it wasn't just about like this metric went up, this metric went down. It was more like you needed to come up with a story behind it. Like, oh, like we made these changes and this happened. And then maybe it's like a 6-month arc or a 1-year arc. And you talk about like all the build up to these changes and these differences, as opposed to like at Facebook, you could just be like, this number went down and that's bad, or this number went up and that's good. Right. And that's where you can have, depending on the company, like how much they put in stock in metrics versus storytelling can tell you a lot about the company. But also metrics are important. Metrics provide visibility. Metrics they explain the world, especially as you get more and more and more of them. The visibility that you get into your data is just better. So and just into your business, because if you have different types of metrics that are measuring different types of things, you can make more clear decisions because you have more visibility into the business environment. And the more clarity and visibility you have, the fewer icebergs you're going to crash into, because you can see a little bit further into the future. And we're going to talk a little bit more about that as we kind of go into more metrics. But keeping in mind, metrics are very important. So what are we talking about today? Well, we have about 5 things that we're going to talk about. So you have metrics play a huge part in data modeling. They, in a lot of ways, they kind of inform data modeling. I'm sure if y'all finished the homework from week 3 on the spec, one of the things you'll notice is that a lot of the metrics that you defined in the spec and the aggregations that you were looking for really did inform what the data table should look like. And that's a big deal because sometimes you can have really funky metrics that people really want and they're just very hard to get or they're very weird to like create a data table for. Especially like if you are getting if you're getting beyond like simple aggregations and counts and stuff like that, it can get very interesting to get the right data model for that kind of stuff. Especially like if you're doing like ratios and denominators where you have A over B or A over B plus C or like any other, like anything that's more than just like a simple count or aggregation, metrics can get kind of funky. So also metrics, make sure metrics can't be gamed. Interesting to get the right data model for that kind of stuff. Especially like if you're doing like ratios and denominators where you have A over B or A over B plus C or like any other, like anything that's more than just like a simple count or aggregation, metrics can get kind of funky. So also metrics, make sure metrics can't be gamed. We'll talk a little bit more in details there. I ran into a couple different cases where I've seen metrics be gamed in big tech companies, and how you can avoid that. There's definitely a lot of different examples there because metric go up does not mean good. Like it's more complicated than that, and that's why you need to have some balancing that needs to be put in place. We're also going to be talking about the inner workings of experimentation. So how does an experiment work? How do you specify test and control? And we're also going to talk about the difference between feature gates and experimentation. Those are they are very related, but also different. So we'll talk a bit more about those. And then to wrap it up, we're going to talk about how to plug metrics into experimentation frameworks. So, for example, we're going to be using StatSig for the lab today. And in StatSig, you can put web loggers in your API and stuff like that. You can definitely do that with StatSig. But the problem is like you might need other metrics that are not easily logged. Like they might be more from like a database or more from like state or something like that need to be more like ETL'd. And we're going to talk more about how to get those metrics into your experimentation frameworks as well. So yeah, let's get into this. All right. So key thing here. When you're doing that spec, the spec stuff that we were talking about in week 3, and you're having back and forths with your stakeholders on what are the business metrics that you should be looking at, this is something that you should be considering at all times. Is if they are asking for something that's more than like a count or a sum or something that's, really just like a group by, like simple thing, like that's going to be mostly something that you should push back on. At least in my experience, like whenever the data scientist is like, hey, we need this funky rolling average sum percentile thing. Generally speaking, as a data engineer, you should push back on that. That's like not your job. That should be their job. And you should just give them the raw aggregates and let the analytics people do whatever sort of analytics and numbers that they want on top of it. So key thing here, don't let the data scientists dictate your data models with extremely like, hey, we need this funky rolling average sum percentile thing. Generally speaking, as a data engineer, you should push back on that. That's like not your job. That should be their job. And you should just give them the raw aggregates and let the analytics people do what this is the spec stuff that we were talking about in week 3, and you're having. This is something that you should be considering at all times. Is if they are asking for something that's more than like a count or a sum or something that's really just like a group by, like simple thing, like that's going to be most like let that on top of it. Just dictate your data models with extremely complex metrics to make you think like you have to add all these other crazy metrics into your data model, because that's not the case. That's not the case, and nor should it be. That's just gonna it's gonna make your life miserable. So let's go to the next slide. Okay, so what are the types of metrics? So in the last slide I was talking about, there's aggregates and counts. Those metrics are great. There's also ratios. You can think of like percent of users in different countries. Talked about like compositions before in a previous lecture. You can also have ratio, which is like percent still active. If you remember from last week, we talked a lot about the retention metrics, right? Or it's like percent of users still active, like the survivorship bias. and those numbers, those ones are interesting, and like because that's going to be like you have A over B in those cases, and so those can be other metrics. Generally speaking, as a data engineer, you should only be supplying aggregates and counts, and what grain you supply those at uh, is usually at like the entity grain. You know, in like week 1 and 2, we talked about daily metrics where you have like user ID and then you have metric name and then you have the value of the metric. Those are going to be, generally speaking, the metrics that you're going to supply to data science. And if they're asking for ratios or they're asking for percentiles or they're asking for anything like that, like they're just trying to give your job to you, give their job to you, and that's not cool. I mean, I used to like as a data engineer, that was a big mistake that I made was I felt like a very confident data engineer where I was like, I can do data science too. So I'll just do it because they asked me to, and I can do data science and data engineering, and I'm a freaking wizard. And for the most part, like I learned that one, you don't get recognition for that in your performance reviews for the most part because your performance reviews are based on how well you do data engineering, not based on how well you do data science. So that is a big minus. And also, you're going to be asked a lot of weird statistical questions around the metrics that you supply that you probably don't want to answer because you aren't a data scientist and that's more their wheelhouse. And I don't know, like I'm fine with answering those questions because I have the statistical foundations to like do data science. But like I don't enjoy those questions. I don't It's not like I'm like, oh my god, like I just am so excited for you to ask about freaking whether or not this is like a normally distributed freaking metric or like all the different things that can happen when they're talking about metrics and definitions and stuff like that. Like, so the key thing to remember is that if you define a metric, you should be able to answer any question about that metric. And so that's why you want to keep them simple because that's not like data engineers aren't meant to be statistical wizards. It's not our job. I look at statistics as something that a data engineer needs to be like 2 out of 10 or maybe 3 out of 10 at to be successful on the job. So you don't have to be a crazy wizard at it. But this is the main idea. You have these 3 types of metrics, and we're going to talk more about like why we have these types of metrics because they're all pretty useful. So aggregates and counts, they're the Swiss Army knife. You should be using these a lot as a data engineer. You can think of like the number, it's like counting events. Like, fact data. is a very common one, like the number of times someone's logged in, the number of friends someone has added, the number of notifications that someone has responded to. Like a lot of those are really powerful metrics, but also other ones are like more like they're like in the middle between like a metric and a dimension. Like is the user active? And like, did they send any messages today? Did they like any posts today? So it's more like a daily active thing, like a 1 or a 0 kind of thing. And those can be very useful, especially when you have a skewed demographic. Like, for example, with notifications, if you make an extremely viral post, the number of notifications that you'll receive is a lot higher, like an order of magnitude or 2 orders of magnitude higher than the average user. But if you have just the notification sent or notification received, yes or no, it doesn't matter if you went super viral or not, because whether you got 1 or a million, it doesn't matter. And we're counting people, not actions. And that's a big thing to remember here, is that there's the 2 different types, right? You can have metrics that are based on the number of people, and then you have also ones that are based on the number of actions. And those 2 different types of aggregates can be very, very important. And we're going to go more in depth into those different types of aggregates later in the lab and in this presentation. So keeping in mind, you're going to have a lot of aggregates here. Another thing to remember is you're going to want to bring in dimensions here as well. There will probably be some specific cuts that people care about. I know at Facebook they really cared about the young generation, trying to get them off of Snapchat and TikTok and getting them onto Facebook. Obviously, given the branding, that doesn't seem like they were very successful, but that was something that they definitely tried to do. And then you have other ones, like there's a big strong push to grow in places like India and Brazil and other countries. So there's probably a geographic dimension that you want to add. And sometimes when you run experiments, they can be statistically significant overall, but not statistically significant in some countries. So we'll go a little bit more into detail there as we kind of go through this presentation. But the key thing to remember about this slide is when you're working with metrics as a data engineer, you generally want to give your analytics partners simple metrics. Okay. Then you have ratios. Ratios are important. And they are something that mostly data scientists should work with, so that, because like you don't want to have to be a data engineer and have to think about like the numerators and denominators and the inclusions and exclusions of different users in the numerators and the denominators of these functions. That's stuff that should be done by the data scientist, because they're going to be better at that like statistical knowledge than you are as a data engineer. Unless you're a super awesome data science, data engineer person, then I don't know, then maybe do both. But even then, I'm more of the opinion of having that be owned by the analytics people, just so that you aren't burdened. I mean, in my case, when I've owned metrics like this over my career, the problem that happens is that like I end up doing both roles, and I'm like answering business questions about these metrics, and I'm like, why am I doing this? I want to just write Scala and do ETL and stuff like that. And then it's like, then I just do both and get kind of burnt out. Obviously, doing both is a good way to get impact, but we can talk about that more later. But anyways, these ratio metrics, you can think of like click-through rate, the number of people who saw your web page versus the number of people who sign up. You also have a purchase rate, the number of people who signed up to the number of people who gave you money. And then you also have things like cost to acquire a customer. Like you might spend, $1,000 on Google ads, and then that gives you 10 users, and then it's $100 a user to get to acquire a user. So you can think of like there's a bunch of different ratio metrics that you can have that are very common. And ratio metrics, generally speaking, they measure not the like amount of something, but they usually measure the quality of something. Like the conversion rate is the quality of your web page. If you only convert 0.0001% of your users that visit your web page, it's probably terrible, right? But if you convert 100%, like, which doesn't happen, but if you converted 100% of the users, that probably means that you had one traffic and it was you, and you signed up, and that was it. right? Because 100% also is like, you should be skeptical. But generally speaking, a good conversion rate is like more than 3 or 4%. If you can get that many people to sign up, that's great. So that's kind of the idea behind ratio metrics. And these metrics are going to be also, they can also be cut by different dimensions. And this is where it's important to be careful, because what dimensions you cut by makes a difference in how you aggregate. Because if you have, for example, say you wanted to look at the number of unique users, or like so you're looking at like unique website user hits divide, or like it's a conversion rate, but like the denominator is the number of unique users who visited, and the numerator is the number of unique users who were there, right? And then if you look at it if you break it out by say like device operating system, then the numbers aren't gonna necessarily add up to the right things, because those you can have someone who's on Android and iPhone at the same time. And so that's where you get this non-additive sort of thing, where it's like, if you look at the conversion rate of all the operating systems and like try to average it out to the conversion rate, and you do like a weighted conversion rate of all the operating systems, it might not equal the overall, because of this additive versus non-additive property of ratio metrics, and like of certain dimensions like operating system, like interface. There's a couple of them that are like that. We talked about that earlier in a previous lecture. But so ratio metrics are all about, indicating quality. Okay, so percentile metrics. Percentile metrics are very useful. So when I worked at Netflix, one of the things that I worked on was reliability of like uptime. One of the things we prided ourselves in at Netflix was we wanted to have 99.99% uptime. So there was only it was 25 minutes a year that you get where Netflix can be down. And we were trying our best to reach that, and we did a pretty good job. So let's talk about the differences here of so if you had a metric that's called P99 latency, what that means is, okay, when our website loads for the slowest 1%, how fast is the website? So it's like essentially it's asking like, how fast is our worst, how fast is our worst experience? And so it's really important if you're trying to optimize the tails of your distribution and capture more audience and capture more share. I know that these types of metrics were also very, very important at Facebook. So one of the things when I was working at Facebook was there was a big push to go global, a big push to get people across the entire world. And one of the things that we realized was, across the entire world, like not everyone had iPhones, not everyone had, or Samsung Galaxy S37s or whatever. Like they all had, like most people in the world, like their phones are kind of low budget. And one of the things that we realized looking at some of these latency metrics and some of these engagement metrics for people in these developing countries was that their phones couldn't handle Facebook, because Facebook was like either too data intensive, too RAM intensive, or like there was just so many different like things, like the hardware of their phones just couldn't handle it. So what these metrics helped leadership understand was that they needed to make another version of Facebook. And that's what they did. They made another version of Facebook called Facebook Lite that was it used, I think, like 20% the same amount of data as regular Facebook, and the install used, like, it was a 90% smaller install, and it also used a lot less RAM. It was also stripped down, obviously. It's funny because, like, I remember at least, like, Facebook Lite, when I was, like, using Facebook Lite for a while, I shifted to using Facebook Lite for a while because it was like a worse experience. And I'm like, I'm already chronically on social media and I want to like not be on social media so much. So I like to downgrade my experience to make it a little bit less addictive. But anyways, it's funny because like Facebook Lite back then really reminds me of like Threads now. I'm like, are they just making the same app again? Like what is going on with Facebook? But anyways, back to percentile metrics. Like, because Facebook Lite was a massive success. Like, it got like hundreds of millions of users, and it was able to get that tail end of users who were not on good enough hardware to enjoy regular Facebook app. So you can look at the tail on that side, but you can also look at the tail on the other side of like, okay, P10 engagement of active users. So in this case, like, what are we doing for people who are like lurking on Facebook? The people who are like, they show up, they scroll the feed, but they never send any messages, they never like any posts, they just like scroll Facebook. And one of the things that there's been studies that show this, that like how you use social media makes a big difference on how it impacts your mental health. And for example, if you're like a lurker and all you do is passively consume, then it impacts your mental health a lot more than if you're a creator and engaging and being more social. Like, if you're more social on social media, it's not as negative to your mental health. So that's another great example of like, okay, what about if we're looking at the engagement metrics for those bottom like lurker people, like what's going on with them, and like how can we make those metrics better? What experiments could we run to try to engage the least engaged people? So these metrics matter a lot because they are looking at the tails. This is where you're going to have a lot of your incremental impact because of the fact that your average user, like for example, Facebook's average user, like, is not going to leave. They're just going to stay because of the fact that they are, nope, Lulu, come here. And they're just going to stay. And because like they're in the meaty part of the bell curve, and they're like, their needs are already being satisfied, and they already are having a pretty good experience. And so that's where you really do want to look at these kind of tail metrics, because that's where you're going to find people who you can actually make their experience better and actually help them come back and engage more. So that's how percentile metrics work. As a data engineer, like, you should probably not be passing these metrics to your data scientist. You should be passing them the daily aggregates, and then the data scientist people can do their percentile magic and stuff like that on the data. As a data engineer, like, you should probably not be passing these metrics to your data scientist. You should be passing them the daily aggregates, and then the data scientist people can do their percentile magic and stuff like that on the data on top of that. They can plug it into their experimentation frameworks, all that jazz. Okay, shifting gears here a little bit. So metrics can be gamed, especially with experimentation. So experiments can move metrics up short term, but down long term. I remember one of the things that happened when I first worked at Facebook. There was an experiment that ran that was like, what happens if we 10x the notification volume in a small subset of the Facebook users? And then they noticed, like, oh, wow, if we 10x the volume of notifications, we get more growth. And they called it like blasts, like notification blasts. And then they were like, wow, we should probably do this more often. And I'm sure a lot of y'all on this call are like, no, please don't. Like, please, I will turn you off. I will silence you. Don't do it. And so, like, and that could be a big thing that can happen, where you can do these short-term, like, gimmicks and games and all sorts of things that can still, like, make your numbers and make your metrics go up because of, like, some sort of, like, short-term reason. But then it's not, like, helping you look at the long term. So the big one for me, right, was in notifications. You send more, you get more users in the short term. In the long term, you lose that handle, you lose that lever, because what happens is more people turn off settings, and then you can't access those users anymore. So what you need to do is you need to create other metrics that can help you figure this stuff out. Like, for example, like in notifications, I created the metric called reachability, which was the percent of users that we can send a notification to. So then when they run experiments where they blast all these users, they can see that it's actually like detrimental. So that made it so that like, and then we had a rule in notifications after that metric came online where the only experiments that got shipped were experiments that increased growth and either were neutral or increased reachability. They had to have both of them going up. Otherwise, like it was going to be an experiment that was considered not successful. So that's a great point when I was talking about earlier, like why do metrics matter? In those cases, like it makes it so that you're not flying in the dark where you're like, wow, like you see now we can see that we're making notifications better, increasing growth, and they're more relevant because fewer people are turning off their settings. So then you can actually get like a win-win. You can set up your experiments to be win-win, not just like gimmicks and games. And so other things you can do, right, with metrics, right, is you can fiddle with stuff. You can fiddle with the numerator or the denominator where it's like, oh, what metrics are you looking at? For example, like you could say, like, I know a lot of them was like engagement per daily active user or engagement per monthly active user. And you can look at these different kind of cross sections of different users. And I always thought it was interesting because like that was one of our goals when I was working there is I worked a little bit more on like email and SMS notifications, which are used more to bring people back on like a monthly basis than on a daily basis for Facebook. And so it's like, okay, but if we look at the engagement per daily active user, then the metric, the experiment might look like a success. But that wasn't our goal to begin with because we're trying to boost the engagement of monthly active users where the effect might be more diminished because of which people are in which populations. And so you can fiddle with the numerator and denominator of your metrics and like you can essentially like get experiments to tell you whatever you want. So that's where you want to be very careful with doing stuff like that and not going too deep into like fiddling with stuff and like really having clear hypotheses when you are on the outs, or like when you're starting your experiment, and that you can test those specifically and look at those metrics specifically so that you aren't like trying to, I don't know if y'all have ever heard of p hacking. P hacking is a great term that I recommend y'all look up, and it's essentially a way to make experiments kind of show significance in whichever way you want them to show significance or not. And so then other things, you have novelty effects. So for example, if you introduce a new feature or you introduce new things, then users will generally speaking, they're gonna be excited by this difference. If you add a new tab, you freaking change your notifications. I know this was an interesting one that I saw was like if you added an emoji to notifications, there was like this at the beginning of the experiment there was this massive lift. It was like a 15 or 20% lift in notification conversion rate if you added an emoji, and people were like. In the notification team, like that first week, we thought we had like we were all gonna get promoted and like, oh my god, like we just struck gold. We just had to put a freaking smiley face in the notification, and who would have thought, right? Oh my god, right? But then like as the experiment kept running, we noticed that the lift that we saw at the beginning ended up starting to die down as the novelty of the new feature wore off. So. And emojis were not the slam dunk to notification conversion that we thought they were. And so that can happen though. And that's why like you need to be aware when you're running experiments for how long your experiment should run. Another example I had was when I was working at Netflix, they were doing these feed refreshes where they were trying to see like if we refresh the movie feed in the background while someone's not using the app and we do a background refresh, does it increase retention because then the movie feed is as fresh as possible? And they tested it out like at different intervals. Like, do we refresh every 8 hours, 12 hours, 24 hours, right? Different like intervals. And they noticed like the more often they refreshed, the more retention they got, which was great. But like, what about the downside of that? Like, if you're only caring about retention, then like obviously you would pick the most frequently refreshing experience. But then it's like, if that adds millions and millions of dollars to your AWS bill because you're just, causing all sorts of additional requests, then that might not be the right play. So another thing to think about. That's why you need counter metrics, and that's what I did at Netflix. Was I added another counter metric, which was the AWS cost of an A/B test. So then they could look and they could see then they could balance it out. They can then do an ROI analysis of we get this much increased retention at this cost. Because a lot of times, you get this thing called diminishing returns, where you do get a little bit more value as you keep increasing that refresh, but it costs substantially more for every interval. At some point, you get this nice little parabola effect, and so, a logistic effect where you hit that kind of carrying capacity where you have to increase the cost a lot more to get a smaller and smaller benefit. So metrics can be gamed. We're going to talk a lot more about this on Wednesday as well. Okay. So now we're going to kind of go back to the fundamentals here of how does an experiment work? So there's really 4 pieces to an experiment. This is very similar to the scientific method. If y'all remember that from school, your first step is make a hypothesis. Then you want to do group assignment. You can think of that as test control. You might have multiple test groups. There could be 2 or 3 or 4 test groups as well. And then you want to collect data. And then you want to look at the differences between the groups. So that's going to be the main things. And we're going to go over each one of these in detail so that y'all can be ready when you are making your own experiments. Okay, so hypothesis testing. The null hypothesis testing is where you have what's called the null hypothesis, and then you have the alternative hypothesis. And the null hypothesis is always the same, which essentially says there is no difference between test and control. There's no statistical difference. Making this change will have no statistical difference. And the alternative hypothesis is there is a significant difference from the changes that you introduce, like the test and control cells. So those are the 2 types of ways that are 2 hypotheses, and these are you can see how these are only one can be accepted, and so let's go into a little bit more details around this because this is an important kind of nuance. So you never prove the alternative hypothesis, right? So in this case, you reject or fail to reject the null. So in the case when there isn't a statistical difference, you fail to reject the null hypothesis, which says that there is none. But if there is a statistically significant difference, you reject the null hypothesis because your alternative hypothesis might not be right. Because it might have more details in what you think is the reasoning behind it. And it's similar in science how you have hypotheses and then you have theorems, and you only really get to that proof level when you have a massive body of work, right? And so you don't really prove hypotheses, you just support them. And that's going to be a key thing to remember here, because of the fact that you can have all sorts of other things that could be going on. So you want to always be that kind of hesitant, kind of hand-wavy data scientist in that case. Okay, so group testing. This is an important point. This is essentially how we assign test and control or to our group members, and in this case, our group members are our users. And then we got to ask a bunch of questions. So one of the big questions to ask is, are these users in a long-term holdout? Like, for example, at Facebook, when I worked in notifications, they had this thing called long-term holdouts, which is they wanted to measure the effectiveness of notifications as a product. And the way they did that was they took a small percentage of Facebook users who we just never sent them notifications, ever. They got no notifications. It's like a small percentage of users get nothing. And the reason why we do that is that we can compare the growth of that group to the growth of everybody else. And then we can see the impact that notification has on a percentage basis. And that like incremental growth, comparing those two groups, was a very critical metric for Facebook. But with that being said, if the user's in a long-term holdout and I'm doing a notification experiment, that user is not eligible for that experiment because they can't get notifications. So you can have these long-term holdouts that are very important because they're like long-running experiments. And you want long-term holdouts because they measure the effectiveness of various parts of your application and the health of those parts of the application. Because you'll have users who don't have that feature, and then you can see like, oh, are these users like how many more users are we getting back because of this feature? And that could be huge as well. And so like make sure that like that's the first thing you want to test is like, are they in a long-term holdout? Another thing to test is like, you might be doing an experiment that is geographic. So maybe I'm doing like a sale in the US, and then it's like, okay, are my users in India eligible? No, because it's a sale in the US. So like a lot of times your experiment groups are not 100% of your users. It can be some fraction of your users based on different criteria that you have for them. Another one might be like, oh, I want to do an experiment on Chrome to see if these users have this bookmark installed, or to have this thing installed on, or like an extension installed, or different things like that. Like, and then your population is just people who use Chrome, not everybody. So you can have experiments that have all sorts of different like criteria to be involved in. And we're going to go over how to set some of that stuff up in StatSig today in the lab. And then another one is like, what percentage of users do you want to experiment on? Because another thing is like, what if your experiment sucks? What if your experiment has a lot of downside to it? You don't know. And that's where it's like, if you're a big company like Facebook and Google, like you can actually really limit the downsized impact, where it's like you might start with like 1% of users or 0.5% of users. And then if the experiment shows promise, then you open it up to a wider number of users to see like how the power and like the statistical trends, that they'll probably stay the same because you have a strong enough statistical sample, but they could shift as well. So that's where like, what percent of users do you want to experiment on? For my experiments that I'm running on my website, I just do 100% because I don't have 10 trillion users like Facebook and Google. So for me to get enough statistical power out of my tests and out of my experiments, I need pretty much every user I can get. So that's where it's important to look at what the differences are there, and like how big tech versus a smaller company is going to do experiments. And a big one here is going to be the percent allocation, because big tech gets that luxury where they can experiment on a smaller percentage of users and see what happens before they open it up to everybody else. Whereas at a smaller company, if you did that, you're going to get like 2 users, and it's like, okay, you don't have enough statistical power to prove that there was an impact or not. So you want to make sure that your tests are powered. We're going to talk more about that in another slide here. Okay, so let's talk about group assignment. So there's 2 ways that you can be essentially assigned to a group in an experiment. The first question is, are you logged in? And if you're logged in, you can have a logged in experience, and your user ID for your app will be the identifier for that user. And logged in experiments are more powerful than logged out ones in some regards, because of the fact that you have a lot more information on your logged in users, right? Like, for example, pretty much everyone in this call filled out that intake form. So I know all, like, the time zone that y'all are all in. I know all sorts of different things about y'all, right? And so if I run experiments on exactly.com that are logged in experiments, I can use that and assign groups and bring in more data and richer data about y'all, because I have so many more like dimensions and different things on like how y'all interact with my website. But on the flip side, like you also probably want to do logged out experiments to see how people convert so that you can get customers. And usually speaking, if you're going to be doing a logged out experiment, you're going to want to use one of 2 identifiers. Like, you can either use an IP identifier, but you want to hash it. If you hash your IP identifier, then that will be a way to get someone to kind of have a stable identification. The problem there, though, is like if someone's on, like, they're visiting your website and they're on mobile, and then they go from mobile to Wi-Fi back to mobile, then that's going to be treated as 2 different users, even though it was 1 user. That's where StatSig is pretty cool. They have this other thing called a stable device ID, which is going to be a more consistent way to hold on to users that you can also use. They have their different trade-offs and benefits, right? And the stable device ID can also be pretty powerful as well. So, and also know that, like, if you use IP, another thing that can happen is if you have 2 people on the same Wi-Fi that are visiting a certain website, they're going to be the same user. So you also get you can have 1 user become 2, but you can also have 2 users become 1. And so you can actually have both experiences happen, like if you use just IP. And so that's where you can, that being said, IP is also very simple to use. And actually in the lab, that's what we're going to be using. So what happens is you pass your identifiers to StatSig. StatSig will then say, okay, server, send the blue environment or the red environment. So you can think of like the different colors as different experiences that users can get. And StatSig will essentially tell the server that, and then the server will send to the client the changed view, like whether it's a blue button or a red button, or you say like data engineering academy versus data engineering course, or different things like that, and you change the words up, so then you can measure the impact of your experiments over the long term. And another big important thing that you have to do is you need to track your events. So if I send a client with a blue button, I need to track all the events, like, so that I know that they got the blue button and then they signed up and then they bought from me, right? I have the whole funnel of events that they did. And so those events can happen either on the client or on the server, depending on where you want to do your logging. And StatSig offers APIs for both, right? You can have you can do client-side event tracking or server-side. For the lab today, we're going to do all server-side because it's simpler. So this is kind of the idea behind how to run experiments. There is one piece in here that is missing, and that is, what about other metrics that aren't logged on StatSig, but you want to add? Like, for example, you might have a user pipeline that you want to add a bunch of other extra dimensions to. So you can have, like, you can imagine like a separate ETL process that dumps into StatSig as well, that gives you like user level dimensions and metrics as well that you can also add. So, and we'll talk a little bit more about that at the very end of this presentation. Okay, so that's the idea behind group assignment. That's how they get into test to control. It's based on those identifiers. Then you collect data. You see, okay, you collect data for a while until you get a statistically significant result. Generally speaking, in big tech, that meant you waited at least a month. So you ran your experiment for a month to see what was going to happen. So, and what I was saying in the previous slide, you want to use stable identifiers, whether that be your IP address or a stable ID in StatSig. And then there's also you can also use your user ID, like your logged in user ID, if you're doing a logged in experiment. We're going to be doing a logged out experiment in the lab today because setting up logged in would be just a lot of work. So collect a lot of data until you get a statistically significant result. But keeping in mind, you might not, especially if you're looking for either a very high level of significance or the change is very nuanced and there actually isn't a statistically significant result. Generally speaking, the longer you collect data, the more likely you're going to get a statistically significant result. Okay, so how it works, right, is the smaller the effect, the longer you're going to have to wait. So if there's a big change and like one version of your test is just dramatically better than other versions, then great, awesome, and then you'll get your statistically significant result very quickly, and that could be it can be a good feeling too, because then you're like, oh, awesome, like my hypothesis was correct and I got my data really quickly. And that can oftentimes be a sign that you have like a slam dunk experiment. And on the flip side, like if it's been a month and you still don't have a statistically significant result, it might not ever be, right? Or the effect might be so small that like it doesn't matter. So keep that in mind when you're like collecting data. Another big thing, do not underpower your experiments. So today we're going to be talking about how to have multiple test cells. So you can have test cells 1, 2, and 3, and then your control cell. You can have different test cells. And the problem is, like, if you have too many test cells, then you're going to run into problems because you're going to have underpowered. Because imagine if you had 10 test cells, then that means that like each cell is only going to get like 10% of the data. And if each cell only gets 10% of the data, then in order to get enough data to measure if there's a statistically significant result is very high. And you don't want to do that because if you're working in a startup, you definitely don't want to do that because you don't have enough data. Google is a little bit different, right? They ran an experiment where they tested 41 different shades of blue, and they were able to send like 2.5% of the traffic to each shade of blue, and then they were able to get enough data back on that, and they didn't have to wait a million years. And the reason why they didn't have to wait a million years is because they just have an insane amount of data at their disposal, and they can do a lot more experiments. That's one of the things that's beautiful about having a lot of data, is that you can run experiments a lot quicker because you have like just more incoming input from people. And remember this is critical, is that like when before you start your experiment, you want to make sure that you have logging set up for all of your events and dimensions you want to measure so that you can check and like you don't have to be like, oh, halfway through the experiment be like, oh man, we forgot to log this other metric, and now and then because then like, you're gonna miss out on a lot, and then it's gonna mess up the differences because like you're gonna have like a skewed experiment where half the people were in the experiment and you didn't log the metric, and then the other half you logged it halfway through, and it's a problem. So that's a big important thing to remember before launching experiments is make sure you have all your logging in place. Okay, now we're getting to the cool parts of this. So you want to look at the data, and here's an example of an experiment that I'm running on my website on exactly.com. And you're gonna, when you're running an experiment, you're gonna look and you're gonna get charts like this that are different metrics, and you can see like the statistical significance, like kind of day over day, or like the different. This is not day over. This is just like comparing test and control. So in this experiment, I'm doing red versus blue buttons, and you'll see if there's a bar that overlaps 0, so if you have negative and positive options, then it's not a statistically significant result. So the only metric that actually makes a difference here is whether or not someone visits the sign up page. And you'll see that, I mean, there's not a lot of data here yet, and that's why these the error bars are so freaking huge. So you'll see in this case, the impact here is 21% plus or minus 20%. So that means that like the red versus blue button could impact signups between 1% and 41%. That's like the range of like what could possibly be here. Keeping in mind that I've only been running this experiment for 2 days. And the confidence interval, right? You see the confidence interval here is only 80%, which is a pretty weak confidence interval. That's not the industry standard in data science. I was like, so technically, like if you use industry standard, this experiment shows that like whether I use a red button or a blue button, there's no statistically significant difference. So, let me show you that like as we talk more about p-values. So in this case, the p-value would be 0.2, which is a very high p-value. That's what we want to look at. So p-values. So generally speaking, p-values are the standard one is 0.05. So what that says is there's a 90, like if the p-value is less than 0.05, that means that there's a 95% chance that the effect that we're looking at is not due to chance and is due to some other factor, right? And it's not due to randomness. And so in the last slide, you see when it's like this 80% confidence interval, that means that for this metric, this visited sign up, the one that's statistically significant down here, that means that there's an 80% chance that this is not random, but a 20% chance that it is random. So keeping that in mind when you're like looking at confidence intervals. And the lower the p-value, the higher certainty you have that the randomness is it's not due to randomness, but due to some sort sort of underlying change. So p-values are very important. If you haven't looked at them, I highly recommend looking into them. They're a statistical tool that are used to pick out change. And they're one of the most important things when running an experiment to determine whether or not we can say that there was an actual change or not. Okay. But just because something is statistically significant doesn't mean that it's valuable. And one of the reasons that is the case is the statistically significant change might be tiny. Like, for example, in that last slide, you saw how, like, I was like, oh, there might be a 1% lift if I use a red button instead of a blue button. And it's like, if it's like a 1% lift, is that even like, I mean, it's valuable, but like, what if it's like a 0.001% lift? Then it's like, okay, that's essentially the same. Even though there is a statistically significant difference, it's the same. And that can happen, especially for experiments that are running for a long time, because as you collect more and more data, more and more metrics, the differences in them will become statistically significant, but the deltas might be tiny. And if they're tiny, like, they're probably worthless. So that's a key thing to remember about statistical significance. Okay, so I want to talk about some other important gotchas with statistical significance. If you have test and control, here's an example for you. Like, so say you're measuring notifications received, and like that's the metric you're looking at in your experiment. And in the test group, you have a bunch of average people, and then in the control group, you have like Beyonce, and you have Justin Bieber, and then a bunch of average people. If you look at notifications received, Beyonce and Bieber are probably gonna have a few more notifications than everybody else, and that's gonna really skew the average up a lot. Where it's kind of like how, in a room of me and Warren Buffett, the average between us is a billionaire. Even though I'm pulling him down a lot, he just has so much money that it doesn't matter. And so it's the same idea here, where if you have extreme outliers, you want to be careful. And one of the things you can do is it's a technique called Windsorization. So if the outliers are so extreme, what you can do is you can clip them to a less extreme value. And generally speaking, that's like the 99.9th percentile is what you want. That's what the standard kind of Windsorization is. So that, like, if you have like just very, very extreme outliers, that will make it so that you don't have as much skew. But another thing you can do is, instead of looking at event counts, look at user counts, because that can, but it depends on like what you're trying to measure. But like a lot of times user counts is going to give you a better view, because in that case, it's like, okay, Bieber and Beyonce both received a notification, so they count as one. And I received a notification, so I'm at the same level as Bieber and Beyonce, right? So anyways, that's kind of the idea when you're looking at statistical significance. Remember that skew can cause problems. Windsorization is often built into different experimentation platforms to help avoid this problem, but it is a technique that you should be aware of. Okay, we are getting real close. So StatSig can create metrics. We're going to go over how they're logged and all sorts of things in the lab today. And how about adding your own? So this is a very common problem, and this is a big problem that I did at Facebook. Was like, as a data engineer, you often are going to be adding new metrics into experimentation platforms so that data scientists can look at how they change via experimentation. And so that's a big thing to remember as like you're building stuff out, is that like a lot of these daily metrics and daily dimensions or slowly changing dimensions are going to be added into your experimentation platform so that data scientists can go nuts to see like if there's like any dimensional impact on an experiment, or like if this metric is important, or what counter metrics you need. So very common thing. I've done this at literally every company I've worked for in big tech.
Congrats on getting to the end of the day one lecture. If you're taking this class for credit, make sure to switch to the other tab so that you get credit for it. Excited for you to check out the lab.
What I want you to do is make sure you're on the latest version of the code base. Pull from main. If you're not, you're going to need to set this StatSig API key environment variable if you have not done that. I can show y'all how to do that if you